Hello and welcome to another Unity 5 tutorial. In the last session we finished creating our UMA initializer, a menu item which gives us all the necessary components and game objects we need in order to work with the UMA system. Also, we've added our first test UMA, so as I hit play, there he is, our stout little guy with pig nose and all, looking around, waiting for some action. So in this tutorial, we're gonna do just that. We're gonna get our UMA to move around in our scene. And as we think about moving a character, there are different options. I'm not gonna go into all the details on how we could achieve moving our character around. I'm gonna focus for now on one method, and hopefully later on I can do another set of tutorials about another method. Anyways, what I've chosen for now is the NavMesh system. So if you don't know what that means or how that works, we're gonna look into that in this tutorial. And we're gonna make it work for our pig-nose UMA. So in order to be able for our UMA to walk around, we just need a bit of a ground for him to walk on. So first thing we do is we add a plane, scale it up, let's say 10 on the X, 10 on the Z axis, and reset the position of the plane. Oh, I'm doing it all in play mode. How often have I done this already? Anyways, big deal, we just do it again. Reset the position, and in our UMA folder there's an example folder. In that one there's a texture folder, and we got a ground texture here which we apply to our plane just to have a bit more texture to it, to know where our UMA is walking and stuff. So great. Now the NavMesh system. Okay, so the way, how do I explain that? I guess if you've worked with rigid bodies before and with physics or in colliders, actually colliders would be all that matters for now. Let's say we got our character here and we add a collider. Let's take capsule collider. Now you get this collider with a radius and a height and an offset, something like that. And as you're moving around, what is sorry, that light is just in the way. Okay, so what is actually colliding is your capsule collider. So there's not a special mesh collider taking in every detail of our character, but as this character walks around with this capsule collider and there's another collider, then the collision would happen as this capsule hits the other collider. And the size and even the position of this collider does not necessarily have to be the same as our character. So we could make it way bigger or smaller, higher. I mean, you can tell that our UMA is now floating around by what I've done, but other than that, it's not really, you see the collision could happen here, and we get an event triggering saying that our UMA just hit something while the UMA is standing here and the collision is here. Anyways, point I want to make is the character, what we see, the rendering and the animation has nothing to do with our capsule collider as we do collision things. Now, or well, nothing is a bit saturated, but I guess you get the point. And the NavMesh system is fairly similar to that approach. So basically what we will do is we create, or let's just do that so you see it. We add a component to our UMA called NavMesh agent. And there you see it. It's also sort of a cylinder in that case. Cylinder got a radius, a height, an offset. fairly similar to our capsule collider. And what's wrong with that light? Okay, so and what we want to do is move the cylinder around. This is what a NavMesh will be used for and what a NavMesh agent does. But we're actually, so the tricky thing we have to do, what will be our job, the job of this and probably the next session, is to get the movement of our agent, which is the cylinder, and of our character aligned. Of course, that is not all, we don't have to do it all manually. So if we now just give this cylinder a destination to go to, it will actually work. We will try that out in a second. Just want to give some more details about the NavMesh system. So we don't need to couple everything, but yeah, let's look into details later. The other component we need for a NavMesh system to work is a NavMesh, obviously. So NavMesh agent by itself doesn't do a whole lot. And in order to get a NavMesh going, we need to hit Window, Navigation, which opens this tab here on the side. And here you got another 3 tabs. So let's start in the middle on the Bake tab. Here you see a little representation of what's going on here. So we have a radius, a height, and a cylinder shape. So that's obviously our NavMesh agent in a world. And there is some more settings like a slope, and it's called max slope. So that means any slope that is higher than 45 degrees, as of this setting right now, our character or our NavMesh agent, excuse me, cannot walk up there. Same for step height. Any step that is higher, where the height difference is larger than 0.4, our NavMesh agent cannot just step up. And yeah, there's some more, some other settings. We're just gonna ignore them for now and just focus on the basics. So another thing is areas. There are some nice colors here with some values. And for now, we're just interested in walkable. What that means, a NavMesh will look for walkable areas. Walkable means those settings are true. The slope is not higher than 45. The step height is not higher than 0.4. And if that's true, then we will have a walkable area, meaning that our NavMesh agent can move around freely on this area. If it's not true, it will be a not walkable area, and our NavMesh agent, of course, cannot walk there. And the way we create our NavMesh is we need to select all the objects we want to consider. So it is perfectly possible to say, I just want to have this plane. I could put a cube in here and say, I just don't care about this cube. Actually, let's just do that to illustrate what I'm talking about. Here's our cube. And now we just start with ignoring the cube. All we want to know is where are the walkable areas on our plane. We can also use this filter for mesh renderers because those are the important ones for the NavMesh system. That's why there's a mesh in the name. Yeah, and here we could now just choose the plane. Now, of course, I guess that's not rocket science either. If you think about how that system is supposed to work, we want to have areas where we can walk and areas where we cannot walk. Of course, there's a difference, a huge difference between static objects and non-static moving objects. And static would mean, of course, our plane will not move around like this unless I write a script and I want that behavior in my game. But for now, let's think of it as a terrain, and that's not moving. So this is a static object. It will not change, and so just the whole process power that would be used for moving objects, we don't need to spend that here. We can just assume this mesh will never move, and that's why we tick the navigation static. So this is actually all. For now, we want to focus on the walkable areas, and so I hit bake, and there you see it, this wonderful light blue area. And right now this is just a square. Of course our plane is a square, but what it does is it takes the radius of our cylinder and it just goes to all the edges and says, okay, I cannot walk past this edge, so I'm gonna stop the walkable area just before the edge, considering the radius of our NavMesh agent. But what I was talking about before, we just did not select the cube, so our cube is ignored by our NavMesh. The NavMesh actually assumes that any NavMesh agent could walk right through here. So if you use the NavMesh system, obviously you want to make sure to have all the obstacles included in your NavMesh, otherwise what's the point of it, right? So let's do that. I'm just gonna select them both. You see the setting is not the same for both of them, so I'm just gonna set it true for both of them and hit bake again, and there we go. Now again the radius is considered, and that's why you have quite a large area around our cube that is not walkable, and this tiny little area around here where character could still squeeze through, or NavMesh agent, sorry. So this is all we need in order to move our NavMesh agent around. So obviously, as we're talking and thinking about creating NPC movement, this would be a huge downside for our workflow, because whenever we change something in our scene or in that area that is relevant for our NPC movement, for a specific NPC, we would need to create a new NavMesh, updating the positions of obstacles, or we would need to set it all to dynamic obstacles, which would be a big hassle, since our CPU needs to constantly watch those elements and constantly make sure none of the obstacles are colliding, stuff like that. So we don't really want that. But as I said, if we want to work with that system, always need to update a NavMesh. Of course, you can use the same NavMesh for multiple NavMesh agents. But yeah, that's just something to keep in mind. This would be a downside. The upside, or yeah, one of the pros definitely is that we have an integrated pathfinding solution in the NavMesh system. That's actually what it's used for in the first place. Meaning we have an obstacle here, we want our character standing right in the middle and we want him to walk past the obstacle. Our character would use the NavMesh, or the NavMesh agent would use the NavMesh in order to figure out where can I walk. So he would walk just around here. We're gonna try that out later on. So this is a neat feature what we can use in our game quite well, I think. It's just nice to know that our NPCs will be able to edge around obstacles. Okay, let's clear this filter. Now, before we get to scripting, I just want to change one more thing. We've added our NavMesh agent. If I hit play, it doesn't fully, doesn't fully match our UMA. I think it's a bit too big, so I've decided on some values here. 0.18 for the radius and the height 1.76. So if I now hit, that might be even a bit too small, but I think that's all right for now. And now, why I'm showing this, if you change these values, now the NavMesh agent we're using is smaller, but if you look at our NavMesh, it did not change at all. Reason is our agent radius and height in our NavMesh baking settings stayed the same. So we need to adjust that here as well in order to adjust our NavMesh. So I'm using the same settings here, 0.18 and 1.76, and hit bake again. And there you see right away the distance from obstacle to walkable area is way smaller, since our NavMesh agent is smaller, and we got more room to walk around here, which should come in handy later on. Okay, so this that much for our setting up things, and now we can start writing some code. So in our UMA tools folder, I'm just gonna put everything in here for now. Can structure it later. I'm just gonna create a folder scripts, and here I create a new C# script. How shall we name it? How about our NPC? Sorry, I'm quite indecisive if it comes to names and stuff. So movement NavMesh. That's not a nice name. But anyways, as I was saying, I want to cover another movement type later on, another way of movements, 1 or 2 maybe. So I just want to make sure to keep them separate and yet be clear about what the script is about, being movements and not the NavMesh itself. Okay, this is our script, and first of all, we need a few references. So we need a NavMesh agent, and we need our animator. Now I haven't really talked about that one yet, so sorry, but I quickly need to cover that. Actually, no, we're just gonna, we want to see something, right? You guys are here for seeing something happening on the screen, so let's do that. Let's forget about the animator for now. And in our start function, first thing we need to do is set our agent. So this will be a get component call NavMesh agent. There we go. Of course, later on we need to fiddle that into our UMA initializer, in our test UMA setup. We don't want to do that all the time by hand. Okay, we've set our agent, and now our agent has this really nice parameter or variable called destination, which takes a vector 3, and we want to set it to some vector 3. So what we need is, let's put it underneath, a public, I'm using a game object, destination. You can also use a transform, or actually let's use a transform, or even a vector 3, but vector 3 in inspector is always a bit of a hassle, so I like to use game objects usually. So now we just create an empty. I'm just gonna reset its position for y value actually, and I'm moving it on the z axis, rename it to destination, and on our test UMA we need to add our NPC movement NavMesh script. What a name. Of course we got an error here since I did not finish that line, and here we should have our destination transform, and I just pull in empty game object on it, and Unity extracts the transform component of this game object automatically. Thank you, Unity. And now we can set the agent's destination to our destination position. So now I've done nothing more than set up a NavMesh agent. I hit play, And you see UMA moving already. So that's pretty cool, I think, that there's not much more to it. Of course, what we've seen so far, we could have done with in our update function with a transform.position equals new vector and just adjust it, or even a move call. So that's not the point, but I think it's nice. Of course, what I've said before, we now just set up our agent and we've set up a destination, and right away our character gets pulled along. So there is some coupling between the, let's click it, between our character, our rendered 3D character, and this NavMesh agent. There's already something happening between the two of them. I guess that's obvious since the NavMesh agent is a component. But what we've seen now, what we of course do not like is that there's no movement happening. Our character is just standing, looking around, doing his idle animation. And we need to change that. Just a quick side note, that our UMA is moving in a particular speed is due to the steering values. So if I just move that up to 7, double the speed, hit play, moving a bit faster, as you could see. So this is where the speed value comes from, and the acceleration, like you can see, the UMA is not right away at full speed, it's accelerating the speed. So that's a nice feature as well of the NavMesh agent. So before we're gonna look into how to use our animator and what to do with it, how to couple the animation and our NavMesh agent, I'm just gonna stop here and we'll continue in the next session. Thank you guys for watching and see you then. Bye.